Hello everyone, my name is Kevin Brooks. I'm the Vice President of Marketing here at DxContinuum, and you're with us today to talk about our platform, what we call our Fathom engine. And I'm here with two of our co-founders, Kanan and Bhaskar, and we'll be diving into the Fathom engine platform here at DxContinuum. Briefly about the company, we have been around since 2012. This company was based upon the idea that predictive analytics can be brought to a more operational footprint within companies, and that you can realize the benefits of predictive analytics at really various points and in all kinds of new ways that it's very difficult to do today in the traditional approaches toward analytics. We are based in California here in Silicon Valley. We've got a predictive analytics platform that we'll be talking about, and it's a patented platform. We have great customers and we have a great team. The customers we work with are some of the largest companies in technology and in their industries. Companies like Adobe, companies like Cisco, like VMware. And really the kind of problems that we've helped them solve really defined our approach to how we build our products and build our solutions. The team here has come together with deep experience across data science and across enterprise software, and we've been able to bring a very high level of ROI and value to our customers in a very rapid period of time. So we're very proud about that. And we look forward to telling you a little bit more about the platform. But before we get started, let me just ask the basic question here. Why would you need a platform at all? Kanan, can you give us a little overview on that?
Absolutely. Thanks for that possibility, Kevin. So that's a very good question. So why do you need a platform? And I think you need a platform to solve a problem. And from my perspective and from our shared perspective, and the reason we started DxContinuum was that we saw a problem with predictive analytics. The challenge is that there's a lot of excitement about all the data that's available and all the data scientists we need to create insights from all this data. But creating models, preparing data and creating models is, I would say, less than half the challenge, right? The greater challenge is in incorporating the insights into operational systems that can be used by end users. And for that, you need software engineering skills. And typically, data scientists and software engineers are like oil and water, right? They don't mix much. And the reason you need a platform is that you need it to make it easy for data scientists to operationalize the models they have. And on the other hand, you need a platform for engineers to be able to stand up these predictive solutions without necessarily knowing all the data science that other data scientists know. Right, and so that's what we thought, because that's the only way to reduce the cost of operationalizing these solutions.
Got it. So our solution, the platform, is called Fathom. It's you can see it here. We'll go through the components, talk a little bit about what's what. But Kanan, maybe you can kind of just lay it out for us. What are we looking at here?
So sure, and so essentially what we're looking at is a platform that supports the entire life cycle of creating and deploying predictive solutions, starting from extracting data from a variety of data sources, to preparing data, to creating models, to executing these models, to creating output and exporting that output to the destination. Right. So we have an end-to-end platform that supports these functions that is exposed through a Java and REST API that can run either on-premise or in cloud, and has a variety of I'll call it storage architectures underneath. Right. We can just work with flat files, or we use databases or Spark without exposing all that necessarily to end users.
So the platform itself sounds like it brings a lot of different components together. So what? What would you use this for? Can you give me an example of like a way this would be applied to something?
Absolutely. So what we've done with this platform is embedded predictive insights inside, let's say, an application. So let's say CRM application like Salesforce. We have essentially out of the box solutions for users of Salesforce, may it be inside sales teams or outside sales teams, to take advantage of scoring and recommendation solutions that have been built on top of the platform. So an example of a scoring solution would be, let's say, an inside sales rep might want to know which leads should they call first because they're more likely to qualify, or an outside sales rep might want to know which opportunities are more likely to result in a win by the time frame that they're interested in, so they can focus their energies on that. Or they might want to know what amount will an opportunity close at, or what product should they add to an opportunity that's already in flight. These are all examples of solutions that can dramatically improve the outcomes for salespeople, and we have documented evidence for that with our customers. But these are all predictive solutions that are embedded inside in console, if you will, so that the sales reps get the advantage of predictive analytics inside the application they're already in.
So the platform itself is not so much, it's agnostic to whatever business function you're using. The application, the way you leverage it would maybe in this case apply to sales, maybe you'd apply it to finance, maybe you'd apply it to something else. Is that fair?
Absolutely, and the only difference is that we suck data from a different source and we push output to a different destination, right? And the rest of the functionality in terms of massaging the data to get the analytical data set, to creating the models, to executing the models, etc., that remains the same.
Got it. So when you look at all the details here, kind of what's under the hood. Walk through a little bit of the components here.
Absolutely, and just take a couple of minutes here. So extraction again, as you might say, what's the big deal? Sucking data, but right from the beginning, because of our enterprise software background, we have designed all these scales to be massively parallel and scalable. So our extraction, for example, can extract, let's say given if it's an Oracle database, can actually extract parallelly from different extents, if that is what is needed. And our ETL layer, moving to data preparation, not that it is a full-fledged ETL engine, but it focuses on some of the complex transformations that are needed to create analytical data sets for model creation. Examples being, if you want to create a cross-sell solution, then given, let's say, opportunity and opportunity line item, you need to create a data set that, for each opportunity, for each product that the company sells, has a data set of a particular shape. And for us, all those are single, transformations, right? One-step transformations for us. So you'll see examples of that later. But this data prep layer is focused more on making it easy to create the analytical data sets that are used for model creation and execution. We have a lot of IP in model creation and execution as well, including the fact that we try multiple techniques, or we take care of a lot of issues that typically are hurdles in operationalizing models. But we'll get to that in a minute.
Yeah, so let's talk about the front side of this for a minute. I mean, obviously the extracting of data and dealing with the data that goes into the models is an important part. Maybe now's a good time to bring in Bhaskar, our chief scientist over here, who can maybe tell me a little bit more about the whole idea of that front component, the prepping of the data, the ETL side. Like what's going on there?
Thanks, Kevin. Thanks, Kannan. As any modeling scientists will know, data prep is a key component of building any predictive models, and a substantial amount of time has been spent in building a robust, scalable, and highly usable, extensible environment for data prep as part of the DxContinuum Fathom platform. A lot of commonly encountered tasks are easily settable and usable through a Java inline API, if you will. For example, we allow multiple tables to be joined and complex calculations that span different columns from different data sets to be created, such that you can create a computed column or a derived column as part of the analytic data set, if you will. We also robustly incorporate the time dimension as part of the data creation. Typically, time is captured. A value that change over time is captured as part of the incoming data set, and we allow complex calculations to be done on top of the time dimension, across time dimension, so that we can incorporate first level and second level derivatives of how things change across time, and use that feature or the extracted features as part of the model creation, which can create substantially higher quality compared to a static model that did not use the time dimension, if you will. We also do in order for us to be able to deal with a situations like where you have categorical variables with a large number of variables, we have special techniques for handling those, where we compute a conditional probability and convert the categorical column into a numeric column. That results in high quality models. There is no loss in quality. The models are highly compressed, and time to create the model as well as the time to execute those models are substantially reduced. So these are some of the examples of complex data prep tasks that are available as part of the DxContinuum Fathom platform. And all of these are available as inline Java API, so that not only the model creation task, which is generally a batch process, if you will, but also the model execution task, which can be like an inline call that you need to execute as part of the scoring, can leverage the data preparation, the complex data transform that happen inside the Fathom platform.
Great. So, but I know there's a lot of ETL solutions out there that do a whole lot of, that's kind of a whole set into itself. So do we do that full ETL inside, or how is our ETL component working?
It's not a full ETL as such. Our focus is to get the right set of toolkit together for building and standing up and maintaining predictive analytic solutions in a fast and scalable manner. And we provide all the necessary joins and necessary transforms to get that as part of the building the predictive analytics solution.
Got it. So it's kind of an applied ETL, really on a focused problem or a focused set of kind of outcomes that we're driving for, as opposed to boiling the ocean type of thing.
That's absolutely right. It is really targeted to building and maintaining predictive analytics solutions.
Got it. So now we kind of, if we move from there then into the model itself, I know this is kind of the grist of the platform. What's different about this? What is different in our approach in the Fathom engine that makes this truly revolutionary here?
We, as part of the Fathom platform, we have brought the various pieces that are necessary and important for building predictive models and executing the predictive models in real life and maintaining the predictive models on an ongoing basis very easy. Like we discussed, we produce, the data preparation layer allows us to build, do complex variable transforms as part of the for model building. In addition, once the data transforms are done and ready, as part of the model building process, we allow the user of the platform to be able to specify various kinds of objectives, so that the predictive model can optimize towards an objective. For example, you can optimize towards accuracy versus precision, and various kinds of accuracies are supported: arithmetic accuracies, geometric accuracies, and weighted accuracies. So we support various kinds of predictive model objective specification. In addition, we support various libraries of modeling techniques, random forests, from random forests to decision trees to neural networks to Bayesian networks, so that the platform explores all the available models for a given data set and figures out the best model that represents the data in the most accurate way for a given objective that the user specifies. In addition, we also support the ability for the cases where the incoming data is expected to have a lot of missing values, in which case the model, because we have a data set that represents the future in its view as part of the model building process, we know what is going to potentially go wrong, and build an ensemble of models that can handle the potential issues that are likely to happen in the future, and be ready with the right set of models, so that we can produce the most accurate set of models coming out of the model creation phase.
So thanks. So how would then a data scientist view this in relation to maybe SAS or R or other things they may be using? Because obviously there's a lot of tools out there for data scientists.
Right, and I think the best way to answer that is the last feature that Bhaskar mentioned is creating an ensemble of models for handling missing columns. That has been automated by us, right, as part of our platform. But if a data scientist were to do it in R or SAS, they will have to do that, themselves, right? And there are a variety of other things that are similar in nature, trying out multiple techniques, or some of the advanced variable transformations that Bhaskar mentioned. All these things that are critical to be able to operationalize these predictive solutions are incorporated into the platform, because we have experienced them and we know how to stand up, let's say, solutions inside Salesforce that are robust across customers in the presence of all these issues. Right, so that is the key thing. So because we have actually created this platform that takes care of these things that are critical to operationalize, as opposed to just explore, the data or find out or create a model or a small set of models that are that work.
Got it. So when you kind of step back and pull the lens out a bit, and you're looking at the Fathom platform here, what are some of the real key takeaways you think people need to understand about this when they're looking at it and trying to get their head around it? Either.
Sure, I think I'll go back to the why. The key takeaways, in my mind, is directly related to why did we build this platform in the first place. And we built this platform to help both data scientists and engineers operationalize predictive solutions, right? So the problem that data scientists have is that the models they create are difficult to operationalize. So you want an environment for them to be able to operationalize those models. On the other hand, we also want an environment that allows engineers who have some familiarity, not necessarily deep data scientists, have some familiarity with data, to be able to stand up high quality predictive models based on just specifying objectives and what techniques to use and the like, without necessarily knowing them. So for us, that's really the key takeaway. We want to enable a larger number of people create and operationalize a larger number of predictive solutions.
Great. Bhaskar, anything to add on that?
Just to add to what Kannan was saying, DxContinuum's Fathom platform is an integrated view into how you can build and analyze and deploy a predictive analytics solution. The integration is essentially the same platform that you use the data to build a predictive view or build a predictive model and see its performance. It is the same configuration, it's the same setup that we can further then take it and put it into production.
Got it. Well, thank you, gentlemen. Obviously, we could have a much longer conversation about this, and we'd encourage anybody interested in diving a bit deeper in what we're doing here to give us a call. We're happy to talk about this. We're very proud of what we've built, and we're excited to share it with you. So thank you for spending some time listening about this today. We are DxContinuum. You can reach us there by the information you see on the screen, and we look forward to helping you with your predictive needs going forward. Thanks very much.